Good morning to everyone. Today the session is to that joints and unconformities. So joints and unconformities are very important role is creating in that civil engineering constructions because of whether it is identification of joints in that earth surface area. So while will be excavation of material while the construction purpose, and for example if you constructed any type of reservoirs and dams, is maybe known about to that which places the joints is available to there. So whether it is in that joints in the future scenarios the cracks will be developed, maybe the leakage of dams and reservoirs. In that context, so every civil engineer they can know about to that joints, and the similar way is in the unconformities also. So today in the session will be on to that joints and unconformities. So before going to the joints, whether it is we know about to the definition of joints. Joints means the fractured zones is available on that different rock masses in that earth surfaces. So either will be fractured, either will be adjacent of rock masses. We call it as a joints. So most of the joints is important dealing with the rocks and that excavation of materials and availability of different types of minerals and availability of different types of groundwater and oil and gases. In that context, we know about to that joints. So why? Because of much importance is given to that. One thing will be. So one thing will be excavation of materials for the construction prospecting, and that groundwater purpose. Those two aspects as a civil engineer they can know about to that joints. So any material excavation purpose, so which material we utilizing for various construction purpose. For example, in the earlier buildings, older buildings are constructed by rock masses only. So before concrete technology, under developing of concrete technology, before using of older buildings, so will be construction of different types of rock masses. So if you seen into the best example of in that older collected bungalows, older hospitals, is those material will be excavation materials will be under rock formations only. So that's why, so joints they can know where it is the availability of groundwater is the much more importance is created to that joints. So classification of joints based on the forces applying of the body. Joints are two types of joints is by classified. One is the tensional joints, second one is the shear joints. So tensional joints means when the rock body is adjacent to due to acting of tensional forces. So we already known. So tensional forces means when the body is there, the forces acting for that away from the body, so we call it as the tensional forces. So these tensional forces acted on that every rock body, so the tensional joints will be identified to that. So the best example is the columnar joints is formed as to the due to tensional forces. So either it is the bodies will be rise to that columnar shape. So that is the best example of tensional forces. So columnar bodies are best example of to the joints. So in the tensional forces, due to acting on the particular rock body, it will be acted as some rough surfaces also we can identify it, rough and irregular surfaces. So we have to identify. So these are the best example is the columnar joints. So best example for tensional joints. The tensional joints are called as the tensional forces will be applying on away from the body. Then the surface will be irregular and rough surface will be developed later on the process. So these joints are called tensional joints. So this is the example of columnar joints due to tensional forces. So due to tensional forces, it will be formed as columnar shape. So this is about the columnar shape. This is the example of in the basaltic rocks. Most of the example for that columnar bodies. So in that our nearest places, so near the Pangidi and Diddukuru in the basaltic regions, in the western basaltic rock formations, we are identified that these type of joints, so it will be called as form as columnar forms. So this is the best example for columnar joints is a tensional due to developing on tensional forces. So this is the real example for in that surface area. So this is about to that tensional joints and shear joints. So shear joints means by acting on the particular rock body through shear forces. So shear forces is nothing but that compressional forces. While acting on the compressional forces on the rock body, the rock will be segregated to different types of formations. This is the so these are the involving that compressional forces. The rocks will be, cracks will be developed, joints will be developed both onto that through compressional forces. So the compressional forces is nothing but to that shear forces. Shear forces means towards the compression in the particular rock body. So it will be a later on process, it will be developed on this type of joints. It will be called as shear joints. So based on the direction, joints are divided into based on three types, that is the dip joints, strike joints, oblique joints. When the joints will be developed along the strike direction, so for example this is called as a strike so for example this is we consider that this is the strike of the joint. The joints will be developed along the strike direction, developing onto the joints, it will be called as strike joints. When the joints along the dip direction will be formed as to that, these joints will be called as dip joints. So when the joints will be developed along the strike, so those joints will be called strike joints. When joints will be developed along the dip direction, so the joints we call it as dip joints. When the both strike direction along the dip direction the joints will be developed, we call it as oblique joints. So based on the direction, joints are divided into three types. So one is the strike joints, another one is the dip joints, another one is the oblique joints. And the strike will be the joints will be developed along the strike direction, we call it as strike joints. When the joints will be along the dip direction, we call it as dip joints. So in the both in the strike direction and dip direction, the joints will be developed, we call it as oblique joints. And finally sheet joints. So sheet joints are developed major granitic bodies. So in the granitic bodies in the overland major desert areas, overland rocks will be weathered due to desertations. So the joints will be developed sheet like structures. So this is the best example for exfoliation, is the one of the example for sheet joints. And engineering considerations. So any civil engineer, they can understand of the joints, so they are definitely known about to that importance of joints. So for example, joints are influencing to that engineering constructions. For example, it will using construction of dams, reservoirs and different alignments of tunnels and highways. It will be very proper investigation needed to in the joints. So definitely the economic point of view it will be increased in the sometimes because of lack of awareness to the joints. So it may be reduced for that, while will be proper knowledge in the joints, it will be economic cost will be reduced to that. So that is one of the fundamental understanding. And many rocks having some leakages. So joints means adjacent of rocks either be displaced, either will be compressed because of due to formation time. So when the any type of leakages will be occurring to that, it will be construction of any reservoir in the particular area in the joint areas. So definitely later on process the water will be leakage in the particular dam site or reservoir site. So that is a fundamental understanding of joints. And many hilly regions So while adding the water, it will be the cracks will be developed. It may be later on process. It will be created of the landslides and avalanches, or small creeps will be developed in the joint areas. So these will be construction. Some disturbances will be occurring in that any area of construction. At the same time, the movement of vehicles and the transportation time. So it will be happen to problems will be occurring in that joint areas. And unconformities. Unconformities means a bridge gap of in the rock masses, overland rocks. For example, a rock having different stratas. So strata means different layers. So rock having different layers. So this is the bottom layer is always the older rocks, and the top layer will be younger rocks by chronological order. So any at a point of time some gap will be occurred, so that particular gap will be called as unconformity. The process of sedimentation on particular time will be gap will be occurred, so that is the difference between the older to younger rocks. So the in between gap we call it as unconformity. So based on the unconformities types wise, 3 types. So based on the types of unconformities, based on that 3 types of unconformities we are identified in that earth surface process. So one is that angular unconformity. Angular unconformities means the bottom beds are always some the bottom beds are always it's showing to that some angularity or some tilted will be identified to that. The upper layer younger rocks are always parallel to the surfaces. So this particular unconformity we call it as angular unconformity. If you seen into that in that better example for that, so this top layer always if you seen into that parallel to that rock masses. The bottom beds are always some angularity, tilted formations will be identified. So this unconformity it is called it as angular unconformity. Angular unconformity it means the bottom beds are tilted. So overland by younger beds are parallelly formed as into that earth surface area. So this particular unconformity we call it as angular unconformity. And disconformity. Disconformities means older beds are always some tilted. Older beds are always some parallel arrangement will be there. The younger beds will be some angularity will be identified. So this will be called as tiltation. We call it as disconformity. So disconformity is the obviously opposite vice versa is angular unconformity. So in the bottom beds are always parallel to that rock masses, older beds. The younger beds are will be formed is that vertical orientation. This particular unconformity we call it as disconformity. And final unconformities means non-unconformity. So there is no identification of variation of two older bed and younger bed. So if you seen in this particular image, the red line will be the red line will be indicates to that the difference between older rock formation and younger rock formation. So these overland rocks are younger rock formations. The bottom layers are called older rock formations. So there is no gap identification of the particular rock masses. The indication of rock variabilities. The bottom rocks are different, the above rocks are different. The particular rock body variances only we are able to identify to that. So that we call it as a non-unconformity. Based on the formation wise unconformities are 3 types. One is the angular unconformity, another one disconformity, another one non-unconformity. Angular unconformity it means the bottom beds are formed as angularly, and disconformity it means there is a difference between tilted beds are occurring into the topmost beds. So that will be called as disconformity. So non-unconformity means there is no change will be identified into that bottom rocks and younger rocks. So this particular unconformity it is called as non-unconformity. So this is about to the today's session, joints and unconformities. Thank you.